In stats, we wrapped up this first handout over probability. We did our simulation about parking yesterday, and we just answered a couple of questions about the basics of what it means to interpret a probability. So this number one here, there's this website that runs statistics, and it says that a randomly selected adult eats, or the probability that a randomly selected adult eats breakfast is 0.61. This means if many U.S. adults are randomly sampled and asked if they eat breakfast then about, keyword is about, 61% of them will say yes. Why doesn't it say if 100 are chosen, exactly 61? Well, it's because of variability. It is the risk of a random sample. Samples have variability. It will be close to 61, but probably not exactly, but probably not exactly 61. This is a matching problem, and these are all proportions, these are all probabilities up here. So you match those probabilities with one of the four statements. The one that is impossible is a 0 probability. The one that is certain is a 1.0 probability. The one that is, keyword, very unlikely is 0.01. Yeah, 0.3 is not a majority. Like majority of the time it's not going to happen. But yet I wouldn't say it was very unlikely. 0.01 is for sure very unlikely. This outcome will occur more often than not. They're trying to say it's like just a little bit over majority, so 0.6. 0.99, it's going to happen just about every time, like really close to every time, but not all the time. So the last two are a little argumentative, but hopefully that made sense. We then moved on to another handout that goes over the basics of probability. So right here we have two dice being rolled, and I wanted to show a picture of what a sample space is. So if I roll two fair-sided dice, these are all the possible outcomes. That is known as the sample space. One way to get your total number of outcomes is to take the number of outcomes per object, per chance experiment. So there's one die. Here's the second die. Oops. There are 6 possible outcomes for that one, 6 for this one. They are independent. I should say first, shouldn't I? They're independent, and when they're independent, you're allowed to multiply to get the total number of outcomes. So 36. And sure enough, we have 36 possible outcomes. The main thing I want you to see here is that this is called the sample space. What is the probability of each outcome? Well, since they are fair, and there's 36 possible, each outcome has a 1 in 36 chance, because each is equally likely. Now, it's also a matter of wording, because I would say this 1 and then a 5 appears to be the same event as this. So if you word it as, what are the chances that I roll a 1 and a 5, regardless of die or dice, then that's different. That's 2 out of 36. But if I call this the first die and this the second die, then it's 1 out of 36. It gets very confusing in terms of wording. They're defining event A as the sum of 5. I don't know any other way to do it than to display the sample space, because it's hard to know all the ways that you can add to 5. So, like, you could do it in your head, but you risk missing one. So, like, here's one way. Here's another way. Here's another way. And another way. And that looks like it. So there are 4 outcomes. This is, by the way, read probability of event A. And we know that P of A has 4 favorable outcomes out of 36. So we're going to say 1/9, or 0.1 repeating. I'm okay with 1/9 though. Moving on, what if we want to solve something that's kind of backwards from the initial question? For example, A is summing to 5, and that was 1/9, right? If they ask you what is the probability of not adding to 5, this is called the complement, in this case, of A. So if you know that A is getting a sum of 5, then not getting a sum of 5 is the complement, because the 2 of them add together. That means, or add together to 1. So P of B is 1 minus P of A. Because aren't there 32 events that don't add to 5? This is a backwards way of solving this, and you can just look at it and know that the answer is 8/9. I mean, if you want, you could count them all up, and you get 32, and then reduce, and you got it. That's a whole other way to solve this. But this complement idea, P of B plus P of A add up to 1. So it's a nice backwards way to solve something. We'll talk more about complements of an event in the next video. See y'all later. Bye.